I'm a first-year PhD student at City University's GI Centre, and we're a group of about 15 research students and academics with a general interest in using visualisation techniques to analyse, to do data analysis. My project is a collaboration project with Transport for London, and the aim is to take a relatively detailed data set from the London bike share scheme and use it to get a better understanding of how customers use the scheme, but also with some particularly detailed data and some detailed analysis, using it to infer something about cycling behaviours more generally. So I've split the presentation up into 3 stages. The first part I'm going to say a little bit about academic research, which has happened relatively recently to try and better understand what motivates cycling behaviour. Then I'm going to go through some work that particularly my supervisor did about a year ago, specifically on the London bike share data set, which applied relatively novel visualisation techniques to try and identify relatively sophisticated space-time patterns of usage. And then I'm going to talk about where we intend to go in the next year or so with the project, and particularly how we might use the project to generalise, use the data set, sorry, to generalise about cycling behaviours more generally. So it's probably fair to say that after a few years of quite significant investment within sustainable transport systems, levels of cycling in particular in the UK remain modest by European standards. And so as a result, this has prompted quite a lot of research, particularly led by the social sciences, into understanding the circumstances and conditions which motivate cycling behaviour. A lot of this work has looked at self-reported cycling behaviours, so there's been kind of really detailed ethnographic studies which have looked at cycling subcultures, and this work's been really nice. And so too there's been more substantive quantitative research, which is they've sort of commissioned public attitude surveys, taking a nationally representative sample of the population and trying to sort of cluster and identify distinct attitudes towards cycling in the public. But it's also pretty fair to say that the extent to which self-reported behaviour, claimed behaviour and claimed attitudes towards cycling represent actual behaviour is not that well understood. There have been attempts to do that relatively recently using GPS devices. So academic researchers have strapped GPS devices onto a sample of participants, usually no more than 100, and they've looked at their cycling behaviours over about a month and kind of done some quite nice analysis on it. But due to the size, due to logistics really, these have been really small sample sizes and they haven't been able to generalise outside of these studies. So the advent of shared bicycling schemes around a lot of major cities in the last few years has really excited research departments like ours. So taking the London bike share scheme as an example, for every journey that's made, there's a digital trace for that journey. So for every journey that's made, we have the docking station, the bike share docking station that it started at and finished at, and also timestamps for those 2 events. And with that data, we can do some relatively interesting analysis. So the next few slides, I'm going to talk about some work that we've already done on the data set of journeys. So firstly, how do we try and understand usage of the scheme as a whole? Well, one of the first things that we can do is some summary statistics, and this is a frequency distribution of travel times for all journeys that are made between September and October of 2010. And as you can see, it's quite normally distributed, but positively skewed. So after about 12 minutes, travel times drop off relatively consistently up until about 30 to 35 minutes, where there's very few journeys. You might be not able to notice that there's a peak at 0 minutes there, and that we assume is probably people unsuccessfully docking a bike. And it teaches that we probably need to be careful when doing some more detailed analysis and creating derived variables with this data, because there might be some anomalies and we might have to clean the data in places. Okay, how about when people travel? Well, this is called a cycle plot, and it shows hourly volumes of use. We're looking at daytime hours, so the far left is 6 AM till 7 AM in the morning, and the far right is 8 PM till 9 PM, and the horizontal line going through the middle is the average hourly flows for that day. So looking at the 7 days of the week for all journeys taken between September and October of 2010 again, 2 distinct patterns emerge. We've got sort of a commuter function where peaks in the morning and late evening at the same time as sort of commuting patterns, and then at the weekend, after a relatively sluggish start, journeys sort of pick up from about late morning right through to the middle of the afternoon. What surprised me doing these calculations was that I'd expect at this time, September to October, this is pretty soon after, about a month after the scheme opened, so I was expecting it to be all about the commuter cycling, because I think it was initially only ever open to London residents at the very start of the scheme, and it certainly wasn't open to other members of the public. But clearly a lot of kind of members are starting to use it for these, what we presumably leisure cycling trips. How about a spatial overview of the journeys? Well, for every journey we've got an origin and destination location, the docking station that you started at and finished at. So one thing that we can do is draw lines between those origin and destination locations. There's a problem with doing that in that there are many, many different origin and destination combinations, and you end up with a really messy visual display because lots of lines overlap and it looks like just one big hairball, so you can't really discern any patterns from it. Here we've overcome that to an extent by weighting each journey flow according to their frequency. So the colour, the darkness of the blue, the transparency and the thickness of the lines are encoded according to their frequency. So you might not be able to see that there are lots of really, really thin lines going on here, which are less frequent journeys. And if they were given equal prominence to these more important flows, we'd kind of give greater importance to the less important flows, and we won't really get a structural overview of journeys. But you might be able to pick out 3, maybe 4 distinct patterns from this view. One thing I should say that for each curve there is a straight end of the curve and a curved end of the curve, and there we're encoding direction. So the straight end is where the journey started at, and the curved end is where it finishes at. So this is Waterloo right here. We've got high numbers of flows out of the City of London. That's Holborn there, and then also central London. Further up to the top, which you can't reach, is King's Cross, and we've got high numbers of flows down to Holborn and then to central London. This nice little ellipse there is like a self-contained ecosystem. So there are bikes that are nicely redistributed around, and Serco, who are the people who are managing the scheme, who are responsible for redistributing bikes, have told us that this is ideal for them because they don't really need to redistribute bikes there. People do them themselves, which is quite helpful.
Is that London Bridge?
No.
Liverpool Street.
This is Liverpool Street, and this is some docking station in the city. I'm not sure which one actually. And then to the left, there to the west of London, we've got sort of a different pattern that emerges. And here we assume it's leisure cycling. So we've got high numbers of flows from the top of Hyde Park, to the bottom of Hyde Park. And then you might be able to see there's really small little circles at docking stations, and that's not cyclists menacingly cycling around an individual docking station. That's we assume people who are cycling around Hyde Park and returning their bikes to the very same docking station that it started at. We can sort of test those assumptions by querying the journeys at different times of day as well. So that gives a really nice overview of journeys for the scheme as a whole, but it doesn't really tell us very much specific information about how individual docking stations are used. I don't know if you've ever used the scheme, but what you really want to know is, right now, right here, are there available bikes nearby where I am? And if so, am I likely to be easily able to drop the bike off at the end of the journey? And Joe Wood, who's my supervisor, has written a really nice application which does that, and this is called Bike Grid. Now this links directly to Transport for London's central database and reports the status, the number of bikes available at each docking station in real time. So this is a map of London clearly, and each rectangle represents a docking station. The rectangles are sized according to the number of the capacity of the docking station, and they're coloured according to the number of bikes that are currently available there. So the darker brown the rectangles are, the more bikes there are available, and the lighter brown, the fewer the bikes there are available. Because we're using a lot of space from that, there's little additional information that we can code, say, for a nice little lookup which tells us how many bikes there are available at the docking station and reports the name of the docking station. But by abstracting space and animated to a gridded view, we can put a lot more information on the graphic. So I don't know if you quite got that, but this is a grid of docking stations. Each rectangle represents a docking station, and it's ordered according to their approximate position in real space. So the top left of the graphic there is the northwest of London, the bottom right down here is the southwest of London. And to give a bit of idea of where we are in real space, we've got the Thames running through it, and also the parks. And this allows us to get a really nice overview of what's happening in real time. I should also say that there's a bathtub type metaphor going on here, so the more blue there is now in a graphic, the fuller the bike station is, the more white there is, the more empty it is. So just to show you the extent to which, try and get back to my presentation. It's the problem with using a map. So just to show you the extent to which commuter cycling sort of impacts on the system, this is 10:30 a.m. on a typical weekday. All the docking stations towards the periphery of London are pretty much emptied out, and all the bikes have moved towards the centre of London. Contrast that with 10:30 p.m. on a weekday. All the central London docking stations have emptied out, and all the docking stations towards the periphery around the stations have filled up. Finally, quickly, you might have been able to notice that there were little line charts running through each of those graphics, and that shows the number of available bikes available in the last 24 hours in those docking stations. So here I've chosen to zoom in on round King's Cross area, so sort of north central London. And Belgrove Street, this one up here, is the docking station at King's Cross, and there is sort of, this is at 10:30 a.m. in the morning, so there are rapidly varying numbers of bikes available there, and that's not people cycling really quickly in at just about the right times. This is Serco, which is the people who are managing the scheme, replenishing the docking station as soon as it empties out. So contrast that with Colshot Street, which isn't far away from King's Cross. That has a more expected pattern for a sort of commuter type docking station, where throughout the day it's emptied out of bikes, and then through the evening it fills up before being emptied out completely again. So I think using these type of techniques, we can say something relatively sophisticated about how the scheme's used. But to date, through this analysis, we weren't able to say anything about individual cyclists, about people returning to the scheme to use the scheme. We didn't know whether or not there are groups of individuals who use the scheme in a particular way, and we're not sure how long members actually stay in the scheme, or if or how the nature of their journeys change as they become more established users. We don't know how sort of individuals respond to particular events, and this is quite an important question. We don't know whether the effect of, for instance, a tube strike on known individuals, or the extent to which bad weather affects cycling. We can look in aggregate and say, yeah, that numbers of journeys decrease in winter, but we can't say which particular known cyclists change their behaviour. So these are the sort of questions that Transport for London are particularly interested in, and as a result they've supplied us with a complete set of member records. So with that we have an anonymised member ID, their gender, the date that they registered at, and the postcode that they registered with. And with that we can link individual members to their journeys. So for every member we can query all of their journeys. And that, I think, allows us to answer some really interesting and quite sophisticated questions. My intention over the next year or so is to sort of classify customer behaviours according to the journeys they make, according to sort of when and how much they cycle. And then querying these classifications using some of the techniques that I've just shown, I want to add some sort of qualitative descriptions to people's journeys. And hopefully we'll add more meaning to them. And then the challenge over maybe a year and a half is to sort of layer these classifications with increasing amounts of contextual data, so that we better attend to the circumstances which give rise to certain cycling behaviours. And then by doing that, the ideal aim is that then we can say something more substantive, more significant about cycling behaviours more generally.